In this video, I'm going to review some of the algebra required for Physics 1 and some of the common solution methods we're going to use. So first, when I say solution, what do I mean? So a solution makes the equation true. So for a very simple case, let's take x minus 3 equals 1. The solution to this equation is x equals 4, and that's the only solution which will make this equation true. And so that's a unique solution as well. So let's take a very simple case of solving such an equation, and I'm going to do a linear equation, which is the first one of our kind of common equations that we are going to see in Physics 1. So keep in mind that when I say linear, it means things like x, not x squared, x cubed, sine x, or any of these other things. Those are nonlinear equations. We're going to discuss one of them later, but for the moment we want only linear equations. So 5x minus 10 equals x plus 6. To solve this, which I hope you're pretty familiar with, move all the similar terms onto one side and the numerical terms on the other, and that is going to get us 4x is equal to 16, and divide by 4, and you get x equals 4 as the solution to this equation. That was very simple. I hope you've all seen it before, but that's solving linear equations. More commonly in physics, we're not going to have just one linear equation, but we're going to have sets of linear equations. And when you have more than one linear equation, the important thing to remember is the following. You need to have the same number of unknowns as equations. So that means that if you have a set of two linear equations, you better hope that those two linear equations have only two unknowns in them. So I'll give you an example of a very simple case of this. 6x plus 4y minus 2 and 2x minus 6y equals 0. So there are two unknowns, x and y, and two equations. Therefore, this is a solvable set. I'm going to solve them using a technique which I'm sure you're very familiar with. I'm going to solve one of the equations for one of the variables, and then plug that variable back into the first equation to find them both. So first I got 2x equals 6y by rearranging that equation, and that tells me that x is 3 times y. I don't know what x and y are, but I know they're related by a factor of 3. So now I'm going to take that and plug it in right here to that equation. So 6 times 3y plus 4y minus 2, that's going to be 18y plus 4y is 22y minus 2, that's equal to 0. And you can move the 2 over there, divide by 22, and you'll get that y is 1 over 11. So now I want to take this y and plug it into something where I have x and y separated, and for instance I've already done that right here, so that's where I'm going to plug it in. So I have x equals 3 times 1 over 11, and that gives me the solution x equals 3 over 11. So in this case, the solution is the pair x equals 3/11 and y equals 1/11. That's the only solution which will make these two equations up here to be always true. So I just showed you a system of equations with a solution. Some systems don't have solutions, and these are systems which violate a certain number of unknowns with a certain number of equations. So I'm not going to go into too much detail, but I will just give you the overview about these. So the first situation is that if there are fewer unknowns than equations, this means the system is overdetermined. Typically there are no solutions which will satisfy every single one of the equations. You can only find solutions which satisfy some set of them. The other case is if you have fewer equations than unknowns, that is underdetermined. And typically what you have is you have solutions, but solutions are not unique. We will occasionally encounter such cases as this in physics. I will point them out to you, but we don't need to spend very much time on them. You just need to know what the basic rules are for finding solutions. So the other kind of equation we will have to solve in this class are quadratic equations. So an example of a quadratic equation is the following. 2y squared minus 2y minus 12 equals 0. So this is a quadratic equation as opposed to a linear equation because of the power of 2 here. And that means that we cannot isolate the y's on one side of the equation and the numerical values on the other. The general approach is the following. I'm going to start by giving you the general form of a quadratic equation. Ax squared plus bx plus c equals 0. The x is the unknown here, just like y was the unknown up here. And the a, b, and c are values which come from the specific problem. So the general form for the solution for a quadratic equation is called the quadratic formula, which is the following. The solution x is negative b plus or minus the square root of b squared minus 4ac over 2a. Hopefully this is very familiar to you. You should be able to basically rattle off that formula in your sleep. The plus and minus here are because there are two solutions to a quadratic equation because there's a factor of 2 right here. So what I'm going to do is I'm going to take this example problem and just plug in the values so you can see what the answer is. And so we get our solutions as 3 and -2. Two solutions because of the power of 2 up here. So if this is just a pure math problem, this would be the answer. You would have two solutions, 3 and -2. In physics, normally there's some reason why we pick one of the two solutions to be the correct one. For instance, if this was actually looking for like the time of flight of an object, then of course you don't want the time of flight to be something like -2. So in that case, we would take 3 to be the actual answer. 3 seconds, for instance.